Alright, this video is an example problem on using the thermochemical equation, which is pretty much a combination of stoichiometry and thermochemistry. So nitrogen monoxide and elemental oxygen react to form, little typo on my part, nitrogen dioxide. Okay, so what is the heat change in kilojoules accompanying the reaction of 1.48 grams of oxygen? Okay, so let's go ahead and take a look at the equation. So nitrogen monoxide is NO. Elemental oxygen is O2, as mentioned in the problem. And then I'm going to form nitrogen dioxide, which would be NO2. So let's write them out. NO plus O2 forms NO2. And then I'm going to have some sort of delta H value of the reaction with this. Okay, I just got to figure out what it is. And how I figure that out is I need to take the sum of the heats of formation of my products, and I need to subtract the sum of the heats of formation of my reactants. But the first thing we need to do is, of course, balance the equation. Okay, so I have 3 oxygen on my reactant side. I have 2 oxygen on my product side. So we'll go ahead and balance that real quick. Okay, 2, 1, 2, 4. Okay, we're good. So we have 2, 1, 2. Oh, sorry, 2, 1, 2 for our coefficients. So let's go ahead and do our heat enthalpy reaction is equal to the sum of the delta H of formation of the products minus the sum of the delta H of formation of the reactants. Okay, so in this case, it's going to be, go ahead and start with this. We need to identify what our heats of formation are. Okay, so if I look at my little yellow sheet that I gave you, okay, nitrogen monoxide, the heat of formation is plus 90.4 kilojoules per gram, or per mole. And then my oxygen, which is elemental oxygen, is 0. And then the NO2 is plus 33.9 kilojoules per mole. In both cases, kilojoules per mole, kilojoules per mole. So I write this out. I'm going to go sum of my products, which in this case will be just my products. So it'll be 2 times, because I remember I need to multiply it by the coefficient, 33.9. Okay. And then that's the end of my products, right? And I'm going to subtract the sum of the heat of formation of my reactants, which now I have 2 of them. So that would be 2 times 90.4 plus 0, because of oxygen is 0. Okay? So do the math real quick. All right, so 2 times 33.9 is going to be 67.8. I'm going to subtract that from 2 times 90.4 plus 0, which would be just 2 times 90.4, which would be 180.8. I take the difference between those two values. My heat of reaction is negative 113 kilojoules per mole, so negative 113 kilojoules per mole. So that's the first part of my equation. All right? All right, now let's do the stoichiometry part of it. Okay, so what is the heat change? So I'm looking for a heat change, which means the symbol, positive, negative, is going to be important. Okay, so what is the heat change in kilojoules accompanying the reaction of 4.8 grams of oxygen? So I'm going to go, 1.48 grams of oxygen. So 1.48 grams of O2, and this is just going to be stoichiometry using dimensional analysis. Okay, now I know that I need to get to moles. Okay, so I'm going to go with 32.0 grams, 3.00 grams of O2 for every 1 mole of O2, right? And then I also know that for every 1 mole of O2, according to stoichiometry, the chemical equation and the heat of reaction, there's a negative 113 kilojoules that are going to be released in this exothermic reaction. So I'll go ahead and do the math. Drop the calculator first, of course, before I do the math. just to make sure it works. 1.48 times negative 113, I'm going to end up with an answer in 3 sig figs, which would be negative 167. Okay, and then divided by 32.00. Of course, knowing my moles cancel out and my grams cancel out, I'm left with just kilojoules, so it should be kilojoules. So negative 167 divided by 32 is going to be negative 5.22 kilojoules. Okay. So remember, if I just said, like what's the amount of heat that was released, then you would just say 5.22 kilojoules. But if I ask you for heat change, then you need to make sure you put the symbol in there, and you need to put the symbol as put it at the beginning or during the initial setup of the problem. That way, it'll always carry over into your final answer. Oops, that's not a negative sign. That's the negative sign. All right. So my final answer, negative 5.22 kilojoules.